In this video, I'm going to show you guys how to do significant figures, or sig figs is how I usually like to abbreviate them. Significant figures just tells you how many numbers to round to when you're dealing with different types of measurements. So first off, we're going to go through on how to identify the number of sig figs in a number, and then how to do calculations with sig figs. So first off, when we're looking at there's two main rules that you can look at. There's a bunch of different rules that you can find out online, but you can condense them primarily down to two different rules. So to start off with, if it is a non-decimal number, so what you will do is start counting at the first non-zero number, and stop counting at the last non-zero number. So for example, if I have, I know it's a little weird with the zero out in front, but this is just for example purposes. So if we have this number here, we're going to start counting with the first non-zero number. So that would be the 1, and we're going to stop counting at the last. So it's going to be this one. So when we go through and count, we have 1, 2, 3, 4, 5, 6, 7. So this has 7 significant figures, or 7 sig figs. So the 1 is significant, the 7, the 3, both zeros, the 2, and the 1. This 0 here is not significant, and this 0 here is not significant. If we're looking at decimal numbers, so you'll start counting at the first non-zero number, and stop at the end of the number. So for example, if we have the exact same number, but it's got a decimal place in it, just randomly put into it. So if I have 0.173.00210, I still start counting at the first non-zero number. So that's going to be this 1. We're going to completely ignore that 0. But now what we're going to do is we're going to count just to the end of the number. So now the 0 is significant. So we have 1, 2, 3, 4, 5, 6, 7. We have 8 significant figures. So to do a couple more different examples, so to start off with non-zero or non-decimal numbers, so it doesn't matter how many zeros are in front of it or behind it with these non-decimal numbers. So I could have the number 100,000. There's only one sig fig in it. Because there's no decimal place, we just have this comma here. Since there's no decimal place, only that 1 0 is significant. However, if I put a decimal place at the end, this messes with everything right here. This now means everything past that 1 is significant. So we have 1, 2, 3, 4, 5. We have 6 significant figures. If I have zeros, again, out front, if I had leading zeros, as some people like to call them, still doesn't matter. Still only one sig fig. But with this one, with our decimal place there at the end, we still have, oops, if I could spell figs right, 6 sig figs, because we start here and count to the end. So with this one, that 1 is still only significant. When we are looking at numbers in scientific notation, so if I have 321 times 10 to the 8th, the only thing we look at, so when numbers are in scientific notation, only look at the first part. And there's a reason for that. So like with this one here, we're only going to look at this part right here. In fact, I'm going to separate that out. So right here, we only have 3 significant figures. Because if I was to write this out as standard, so if I change this to standard notation, I need to move my decimal place. I probably should make this actually look like 10 to the 8th. I'm going to have to move my decimal place 8 times to the right. So 3, 2, 1, so there's 1, 2, 3, 4, 5, 6, 7, 8. If we look at this one, we start counting, since there's no decimal number, no decimal point in this now. We start counting at the first non-zero and at the last, so we still only have 3 sig figs. When you change numbers from scientific to standard or from standard to scientific, you do need to keep them the same number of sig figs. So